the person and the detector, if they are in different medium, and if that medium also, if it propagates. Okay, first let me divide this. So there's a first person is there. So let this be a, it's a source of sound. It's a source of sound. So it can be, it is moving with a speed, VSL, right? Speed of sound in this medium, let it be V1. Speed of sound in this medium, let it be V2. So there's a medium one, and the person is here, is approaching with a speed VO. Let's take this one. So there's a medium two. What are V1, V2? Speed of sound in different mediums. What happens if the observer and the source, if they are in different medium? So there's a siren. Just imaginary. What are V1? V1 and V2 are speed of sound in medium 1 and 2 respectively. Now what to do now? So this is like some boundary, no? So as a mediums, no, let me just give color so that it'll be easy for you. So there's a one medium. This other medium. Okay, how to manage this? Okay, no, things are very clear. Check it now. So the waves generated by this at a frequency f will arrive at the boundary. So here f is the frequency, actual frequency of this one will arrive at the boundary. Let it be f dash. So what is the boundary? The boundary will be like a secondary observer. It will receive the waves at a frequency f dash. Is there relative motion between the boundary and the car? Yes. What is Vs, velocity of the car? I'll take Vc, better velocity of car. There's the velocity of person. Then the relative motion between the boundary and the car is the relative motion. So it's not going to receive, the boundary is not going to receive the waves at frequency f at some other frequency f dash. Again, what is boundary? It will permit a part of wave will be reflected, a part will be transmitted. The transmitted wave, due to transmission, frequency will not change. Frequency will not change, we know it. So the transmitted wave will propagate here. Then here it was f dash. It is going to be heard at some other frequency, say like f2 or f1, any other symbol. F double dash, right? Apparent frequency. Now, first, shall we discuss the Doppler effect between the car and the f dash? So, what is f dash is equal to? Now, what is f dash? We should call frequency of waves received by boundary. So, how to get that f dash first? F dash Doppler effect between the boundary and the car. So, this will be v minus okay, this will be only what is v? V is v1, no, first medium v1 speed of sound. So v1 f by v1 minus vc. No problem with this. V1 f by v1 minus vc. Then there'll be f double dash. What to write? frequency of waves received by person. Now the boundary, what happened, will behave like a source. Is there any relative motion between the person and the boundary? The boundary will behave like a source. So what is the now here? What is the first case? Received by boundary. Boundary behaves as an observer. Now next again in the second case, the boundary behaves as a source. Boundary behaves as a secondary observer. Boundary behaves as a secondary source. Okay, what is f double dash? F double dash equal to speed of the sound in second medium is v2, no? v2 into f dash by v2 plus vp. What is vc? Velocity of car. What is vp? Velocity of person. What is f dash? Substitute here now. This will become v2 into v1 f by some correction is there. Just check once. It should be like this, no? Because the observer is approaching the source. In the numerator, it should be the no, v2 plus vp by f dash. What is the speed of the sound? Is v2 in second medium. Now we'll substitute here. What is f dash? v1 f by. Okay, some simple approach. Whether if the source and the detector, if they are in different medium, you can use this method. Sir, if the boundary is also moving, if the boundary is also, that changes is what you're going to make it here. F dash, what is f dash? F dash is the speed of the waves received by the boundary. Frequency of waves received by the boundary. So boundary is attached. It will behave like a boundary. How it will behave like in a secondary observer. This will behave like a source. So V1, what is the speed of sound in the first medium? V1 F. V1 minus Vc. Speed of the sound minus, there is a source, no? We'll get V1 minus Vc. Next, the same boundary will transmit the, due to transmission, frequency will not change. So F dash, F double dash should be equal to F dash into, the boundary will be like a secondary source and the person will be observer. V plus V2 F dash by V2. Substitute that F dash here. You should not apply directly here. You should first get the boundary into the picture. The boundary will act like a secondary observer for the source, secondary source for the person. If the boundary is also moving, where any changes will you make it? Any changes will you make it? S here, if the boundary moving. If the velocity of the boundary is given VB, that you are going to write it here. Try to work out. Even the boundary is also motion, let it be that one. The similarly, how the for wall we did, no, the same idea is what you can implement here. Okay, got this. So these are about the some related to the different mediums, the wall, reflected, echo, that one. Okay, now we'll take the next set of numericals. It's a very lengthy topic. Huh? So many cases will come. A student should have the patience to work out the different cases here.